In this question, we are told that the volume of the frustum is 4,212 over 25 pi. So we are supposed to find the value of x. How can we go about this particular question? And because you can see the radius of this base is actually 6 centimeters, and we are going to call this as radius capital R, and I'm going to call this small r. Then the volume is given as 4,212 over 25 pi. So we are supposed to find the value of r. So something I need you to agree with me is that for us to work out the volume of this frustum, we need to work out the volume of the entire cone minus the volume of the small cone at the top. So we are having two cones at this given point here, the smaller cone and the original the bigger cone. So in order to get this volume, you need to subtract the smaller cone from the larger cone. So one important information we need is the formula you can be able to use to work out volume of a cone. Remember, volume of a cone is given by a third pi r squared times h. A third is actually a third pi r, or base area, a third of the base area times the height. So which means that we need to know the height of the entire cone, which is given, already it's given here. We need to know the height of the small cone. But before we go, let us work out the volume of the entire cone. This is going to be equal to volume is equals to 1 over 3 pi. The radius is actually 6 times 6 squared times the height, and the height in this case is 15. So if we work out that using our calculator, let's see what we are able to get. Let me just work it out so that we can see what we are getting. So we are saying that at this point we are going to say a third times pi times the radius is 6, so that is 6 squared times the height, which is 15. So this is going to give me 180 pi. So if I work out this, I'm getting 180 pi as the volume of the entire cone. Now, the volume of the smaller cone, we need it, but we need to know what this height is. So how are we going to go about that? Because we don't know basically the height of this cone. So in order to work out this, let us say linear scale factor is going to be equal to radius of the big cone divided by the radius of the small cone. I'm going to use similarity and enlargement in order to work out. So our linear scale factor basically is going to be actually x. That is the radius of the big cone, which is 6 over x. Then from the linear scale factor, we can be able to find the volume scale factor. Volume scale factor. And the volume scale factor is actually linear scale factor cubed. That is how we get the volume scale factor. So in that case, it's going to be 6 over x cubed. And if we cube this, let's see what we're going to get. 6 cubed is actually equivalent to 216. 6 cubed is 216. So we can say the volume scale factor is going to be 216 over x cubed. So how are we going to use this information? Because we have the volume of the bigger cone, we can now say using this volume scale factor. We shall say this is going to be volume of the beacon divided by volume of the small cone is going to be equal to the volume scale factor. So that is a relation we are trying to form, which is going actually to enable us work out this particular question. Now remember, we know the volume of the beacon already, 180 pi. The volume of the small cone, we don't know it, is going to be equal to 216 over x cubed. So if I rearrange this, I'm going to have the volume of the small cone is going to be equivalent to what? It's going to be equivalent to 180 x cubed pi over 216. That's the volume of the small cone in terms of x. So once we have gotten here, the next thing that we are going to do is to, because the way we get, okay, let me just, the way we get volume of the frustum is actually the volume of the bigger cone, I mentioned that, minus the volume of the small cone. The volume of the frustum, volume of frustum is actually volume of the big cone minus volume of small cone. So already we have the volume of the big cone here. So we are going to say this is going to be equivalent to, so this is going to be 180 pi minus the volume of the small cone is 180 x squared pi over, this is over 216. This will be equivalent to this value that we were given at that given point. So we are going to say that's going to be 4212 over 25 pi over 25 pi. So we can decide and cancel, because I can see pi and pi can cancel out, so that we are going to remain with 180 minus 180. This is actually x cubed, 180 x cubed over 216 equals to 42 1225. So we are going to now work out this, and we are going to say this is going to be 180 divided by 216. This translates to 180 minus 5 over 6 x cubed equals to 4212 divided by 25. Yeah, that one, we can leave it that point. So meaning we can now bring this 4212 over 25 on this other side, and we take this on the other side. So it will be 180 minus 4212 over 25 equals to 5 over 6 x cubed. So 180 minus 4212 over 25, we're going to get 288 over 25, which is going to be equivalent to 5 over 6 x cubed. Then in order to remain with x cubed, we are going to multiply by 6 over 5 by 6 over 5 both sides, so that this will cancel out and this will cancel out. Our x cubed is going to remain as, this is 6 over 5 times 288 over 25. So if we work out that, we are going to get our answer as 1728 over 125. Remember, we are trying to find the value of x, so meaning we are going to find the cube root both sides and cube root here. So our x becomes, if we work out that using our calculator, I'm getting my value of x as 12 over 5, 12 over 5, which is actually equivalent to 2.4. This is 2.4 centimeters as the answer. So that is how you do a question which involve frustums. And if you have found value from this particular video, consider subscribing so that anytime I'm going to upload new tutorials on the same, you'll be notified.